Hey friends, this is Jim here at Science Talk. Okay, got some troubling news from Greenland. Okay, ominous cracks form in the northern hemisphere's longest floating glacier. A floating tongue of ice in one of Greenland's largest glaciers suffered a bad break in 2012, releasing an iceberg about the size of Manhattan. Now, new cracks in that glacier are indicating that another very large chunk may soon, could possibly, break away. After a massive iceberg separated from Petermann Glacier in 2012, the glacier's slow but steady momentum toward the sea accelerated. Since then, its flow rate has increased by an average of 10%, according to a new study. The study has been published in the Journal of Geophysical Research. The co-author is Dr. Nicholas Neckel, who is a glaciologist with the Alfred Wegener Institute Helmholtz Center for Polar and Marine Research, AWI, in Bremerhaven, Germany. Should the new cracks widen and fracture into an iceberg, the glacier's flow would likely speed up even more, leading to greater ice loss. In other words, if you break off what's holding back the land stuff could start accelerating, moving forward faster to the sea. Petermann Glacier spans about 500 square miles, about almost 1,300 square kilometers, in northwestern Greenland, and is one of only 3 Greenland glaciers with an icy tongue, which basically is found across the fjords and into the sea, North Sea. Measuring 15 to 20 kilometers, 9 to 12 miles, wide, and approximately 70 kilometers long, 44 miles, Petermann's tongue is the northern hemisphere's longest floating glacier. Floating means that it's not anchored, it's not sitting on bedrock, that it's actually extended and you have water underneath it. So eventually especially if you having increased warming oceanic temperatures, as the water warms, it can start eroding from underneath. And eventually the whole thing can just snap right off. In 2010, Petermann Glacier lost about 25% of its tongue in a single break. The ice island that broke off measured at least 100 square miles, 260 square kilometers, long and over 213 meters thick. Thick, that's height, 700 feet approximately, which is about half the height of the Empire State Building. The 2010 incident did not significantly affect the glacier's flow. However, the 2012 break did. It produced a detectable glacier speedup, the researchers indicated in their report. In 2016, the glacier's flow speed was about 1,135 meters per year, 3,000 feet per year. It increased around 10% from 2011. And that was a statement from Dr. Neckel. When the glacier flows to the ocean, the rock walls on either side of the long tongue act as a drag and reduce the speed. But the shorter the tongue, the less lateral pressure and friction there is holding the glacier back. This limits the braking effect so that the glacier begins flowing faster. This is a statement from another author of this study, and AWI ice modeler, Martin Ruhkamp. Now, with the new cracks that have been detected, the new cracks about 8 miles, 12 kilometers from the new edge, the computer models that demonstrated the glacier's accelerated flow after 2012 also predict that Petermann's rush toward the sea will speed up if more ice breaks off. This is what the researchers wrote in their study. The resulting ice loss could cause sea levels to rise. Well, that is to be expected. We So Dr. Rukamp states, we can't predict when Petermann Glacier will calve again, or whether a calving event would actually calve along the cracks we identified in the ice tongue, but we can safely assume that if it does come to a new calving event, the tongue will retreat considerably and the rock's stabilizing effect will further decline. So, we're seeing accelerated melting of Greenland's ice. We're seeing accelerated melting of Antarctica's ice. Now we're seeing potentially more breakoffs from the Petermann Glacier. We're seeing breakoffs from the Antarctica ice sheets as well. Things are accelerating, and now glaciologists are realizing that their models, their estimates, have been underestimations, and that things are actually more dramatic than previously considered. So, what will happen after all of this? We have to stay tuned. Probably going to lose a lot more ice, but now, as you get that ice, that fresh water melting in the North Atlantic, in the Arctic Ocean, remember what I said about the deep water formation. The question is there enough thermal inertia to overcome those effects? I discussed with you countless times before about how the slowing down of the deep water could tip us into an ice age, that the deep water and the conveyor belt is the heat distribution mechanism. Check out all my videos that I've done about that, talking about that. But this is another ramification of what's happening. So, some alarming news. Basically, the overall take-home is that there's probably going to be more ice loss off Petermann Glacier, adding to water in the ocean and sea level rise. Thank you for your time. Hey friends, this is Jim reminding you to subscribe and share my videos. Also, don't forget to click the bell so that you know when I drop a video in. And I'm also asking for you to please support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your continued support.